Hi. In this video we're going to talk about how do we sketch parametric equations and rewrite their equations in rectangular form. Well, first of all, a parametric equation is an equation that can express the position of an object as a function of time. And typically you have two. Think about the parabolic flight of a golf ball being hit off the ground and then landing on the ground. Sure, we can get a quadratic that models the flight, but this doesn't tell me the whole story. It doesn't tell me how long these things took. So we need vertical and horizontal equations as functions of time. And those equations would be x of t and y of t. Or if you've had a physics course, it's usually dx or dy. These are two equations that express the position of this object as functions of a parameter, time. Now, time's not always the parameter, but most of the time it is. So here I have two parametric equations, and we're going to sketch the curve by building a table. So x is equal to t plus 1, and y is equal to t squared minus 2t. So for my table, I'm going to fill out for t from negative 2 to 3. So next, I'm just going to figure out if t is equal to these, what would x be, and what would y be? And I'm going to fill in the table. If you want to do this yourself, pause the video. Alright, so now I've got the whole table filled out. Now I'm going to plot these x and y coordinates. So the very first point I'm going to plot is negative 1, 8. So I go negative 1, 8. Then the next one is 0, 3, and so on. Now hopefully we can see that this is forming a parabola. So at 5 we'd probably be right back at 8, which we would be. But what's important here is that whenever I go to connect these dots, I need to indicate the direction that the graph was formed. And the graph was formed in this direction as time continued. Hopefully you can see these little arrows. So the parametric didn't just give me this parabola, it told me that it went like this over time. It was formed from left to right. Alright, so now we're going to eliminate the parameter t in each equation and write it in rectangular form. Rectangular form is just the form that you're used to. And we're also going to state the type of curve. So let's do this. What we're going to do is just solve for t in one of the equations. For me, that's easier in the first equation. X minus 1 is equal to t. Next, I just want to substitute that into the other equation. So y equals x minus 1 squared minus 2 times x minus 1. After a little algebra, I get y equals x squared minus 4x plus 3. And when you know it, that is the equation of this parabola right here. You can even see this plus 3 is my y-intercept. So now let's look at parametrics with an angle as a parameter. So we're dealing with cosine and sine. We're going to do this the exact same way, but we're going to use the unit circle to build our table of values and graph. To make this a little bit easier on ourselves too, we'll just use really nice values from the unit circle. We'll just use the axes. So we're just going to use 0, pi over 2 pi, 3 pi over 2, and 2 pi. Well, the cosine of 0 is 1, so 1 times 3 is 3. Then we're just going to go around. Cosine of pi over 2 is 0, so 0 times 3 is 0, and so on and so forth. We can do the same thing with sine. Sine of 0 is 0, so this would be 0, 2, 0, negative 2, 0. All right, now let's plot these points. We've got 3, 0, 0, 2, negative 3, 0, 0, negative 2. What can you guess this shape is? And if you need a few more points, sure, just try out like pi over 4 and things like that. But you should see that this is an ellipse. And the way it was formed was counterclockwise. Just because that was the order of the points as we went around the unit circle. So again, this is an ellipse. Look, it centers at 0, 0. It goes out 3 in the x direction on each side, and it goes up and down 2. Let's verify that by converting it to rectangular form. To write in rectangular form, what we're going to do is solve for sine and cosine, and then use the Pythagorean identity that sine squared plus cosine squared equals 1. So solving for cosine, I get the cosine of theta is equal to x over 3. And I get the sine of theta is equal to y over 2. Now because sine squared theta plus cosine squared theta equals 1, then x over 3 squared plus y over 2 squared is also equal to 1. Now again, let's look at the drawing that we just made. This can be written as x squared over 9 plus y squared over 4 is equal to 1. Or just as an ellipse centered at 0, 0, and a squared is 9, so a is 3, 3 out in each of the x directions, and b is 2, so up and down 2. Wonderful. What if we add x equals sine theta and y equals cosine theta? See, the difference here is that this time x got the sine, and usually x is related to cosine. Now this you can see in just a few steps of filling out a table. So I've got some axes here. This is going to go between 1 and -1. So if x is the sine of theta, what's the sine of 0? It's 0. And the cosine of 0 is 1. So the very first point that I plot is 0, 1. The sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So the next point I plot is 1, 0. And what's going to happen at pi, we just go back to 0, and the cosine of pi is -1. And this would just continue all the way around, but notice that this time the orientation is different. Whenever x is with sine, it travels clockwise, unlike the previous example that traveled counterclockwise. So x with cosine, counterclockwise. X with sine, clockwise. So we don't always have to make a table. Because we just got out of conics, you can just solve these and graph it. So start by solving for just sine and cosine in each of the equations. We should have x minus 1 over 2 equals sine, and y over 4 equals cosine. Now square both of these equations and add them and set them equal to 1 because of the Pythagorean identity. That gives me x minus 1 squared over 4 plus y squared over 16 equals 1. So whenever I go to graph this, I know that it's centered at 1, 0. In the x direction, I'll go 2 in each direction. And in the y, I'll go 4. And then whenever I connect these things, because x was with sine, as we can see here, I know that this traveled in a clockwise direction. All right, and that's going to be your intro to parametric equations. There's so much that we can do with these, but we just really got to get down that all of these functions are they're just telling us what's happening in the x and what's happening in the y, just separately over time. And then we put them together to make a graph. All right, goodbye.